Hello guys, how is going? Today I am going to introduce a very important topic with you. My today's topic is Markonikov's and anti-Markonikov's rule, which represent the addition of an asymmetric reagent with an asymmetric alkene. So guys, no more waiting, let's start with Markonikov's rule. Markonikov's rule is when an asymmetric reagent adds to an asymmetric alkene, the negative part of the reagent becomes attached to the double bonded carbon which bears the lesser number of hydrogen atoms. So my dear friend, if you want to know these rules properly, you have to know what is asymmetric reagent and what is asymmetric alkene. Asymmetric reagents are those reagents which has positive and negative parts, and these positive and negative parts are different. For example, HBr, HCl, H2SO4, HOCl, these are asymmetric reagents. But hydrogen, chlorine, nitrogen, oxygen, these are not asymmetric because positive and negative both parts are same. So this is the difference between asymmetric and symmetric reagent. On the other hand, what is asymmetric alkene? The alkene which has different number of hydrogen atoms in the double bonded carbon atoms. Here propene is an asymmetric alkene because here these two carbon atoms has different number of hydrogen atoms. Here is butene. This is another example of asymmetric alkene because these two carbon atoms, double bonded carbon atoms, has different number of hydrogen atoms. But in case of ethene, this is not ethene. This is not an asymmetric alkene. Why? Because the number of hydrogen atoms are exactly equal to the double bonded carbon atoms. So Markonikov's rules is not applicable for ethene. Only asymmetric alkene can react, can give Markonikov's rule. For example, when propene react with HBr, produce 2-bromopropene. Why bromine attached to the red colored carbon atom? Because bromine is negative part of the asymmetric reagent, and as you know from Markonikov's rule, the negative part of the reagent, asymmetrical reagent, become attached to the carbon, double bonded carbon, which has lesser number of hydrogen atoms. Between these two carbon atoms, double bonded carbon atoms, red colored carbon has only one hydrogen atom, and the black colored double bonded carbon has 2 hydrogen atom. So negative part bromine must add to red colored carbon atom. This is Markonikov's rule. Now we should know about the mechanism of this reaction, how this reaction happened. In the first step, hydrogen bromide ionized to produce an electrophile and a nucleophile, and the electrophile is H plus proton and the nucleophile is Br minus bromide ion. Now in the second step, this bromide ion, this H plus ion, that means proton, attacks the double bond, and the double bond homolytically breaks, heterolytically breaks to produce 2 carbon cation. When this proton attached to black colored carbon atom, it produces 2-degree carbocation. On the other hand, when H plus become attached to red colored carbon atom, it produces 1 degree carbocation, and between 1 degree and 2 degree carbocation, 2 degree carbocation is more stable. Now in the third step, bromide ion, that is nucleophile, loves to attach 2 degree carbocation, not 1 degree. In the third step, the nucleophile bromide ion loves to attach the red colored carbocation, that is 2 degree carbocation, and that's why bromide ion attached to the double bonded carbon which has lesser number of hydrogen atom, and the main product should be 2-bromopropane. This is the mechanism of Markonikov's rule. Let us see some examples. When HOCl react with propane, the negative part, that is OH minus, become attached to red colored carbon atom because it has lesser number of hydrogen atom. On the other hand, when sulfuric acid react with propane, the OSO3 minus negative part become attached to red colored carbon double bonded carbon atom because it has lesser number of hydrogen atoms. So my dear friends, to understand well, keep practice. Now we want to know about anti-Markonikov's rule. This is very much similar to Markonikov's rule. The only difference is this reaction occurred in presence of a catalyst named peroxide. And let us know what is anti-Markonikov's rule. When asymmetrical reagent adds to an asymmetric alkene in presence of peroxide R2H2O2, the negative part of the reagent becomes attached to double bonded carbon which bears a higher number of hydrogen atoms. In case of Markonikov's rule, the negative part become attached to lesser number of attached to the carbon which bears lesser number of hydrogen atom. But in this case, in presence of peroxide, the negative part of the reagent, asymmetrical reagent, become attached to higher number of attached to the carbon which has higher number of hydrogen atoms. That's why this reaction is called anti-Markonikov's rule, because this is reversed to Markonikov's rule. For example, here negative part, that is bromine, attached to red colored carbon atom, double bonded carbon atom which has higher number of hydrogen atom. So in this case, the product will be bromopropane or propyl bromide, not 2-bromopropane. If you occur this reaction in absence of H2O2, the product should be 2-bromopropane. That is Markonikov's rule. It will follow Markonikov's rule, but in presence of H2O2, negative part become attached to a higher double bonded carbon which has higher number of hydrogen atom. That's why the main product will be bromopropane or propyl bromide. Now we have to know the mechanism of this reaction, how this reaction happened. At first, R2O2 breaks homolytically to produce RO free radical. This RO free radical attached to hydrogen bromide to produce bromine free radical and ROH. Now this bromine free radical attacks the double bond and form more stable carbon free radical. At first, this pi bond breaks homolytically to produce free radicals. Then bromine free radical, when attached with red colored carbon free radical, it produces 1 degree carbon free radical. and when bromine free radical attached with black colored carbon atom, carbon free radical, it produces 2 degree carbon free radical, and between 1 degree and 2 degree carbon free radical, 2 degree carbon free radical is more stable. So in third step, here bromine attached to the double bonded carbon atom which has a higher number of hydrogen atoms. That's why this reaction is called anti-Markonikov's. Now let us see some example. Here, when ASOCl react with propene in presence of H2O2, the negative part OH must attached to the double bonded carbon atom which has a higher number of hydrogen atoms. So OH minus become attached to red colored carbon atom, and the product will be like this. When sulfuric acid attached to propane in presence of H2O2, the negative part, that is OSO4 minus OSO3H minus, become attached to red colored carbon atom because it has a higher number of hydrogen atom than CH. So my dear friend,